Hello students, this is Dr. Diaz and I'm here to talk a little bit about the redox reaction, which is one in which electrons transfer course. Oxidation is loss of electrons, oxidation number increasing during oxidation. Right? Reduction is gain of electrons, so oxidation number decreases during oxidation. It's very important to know the rules for assigning oxidation numbers. For example, the first rule here is the rule of a neutral atom of an element. That must be zero. So you have copper, hydrogen, it's always zero. Okay, so a neutral atom of an element, its oxidation number is zero. Rule number 2, monatomic ion. So if you see charge, the oxidation number will be equal to the charge. Ions in ionic compound, for example, sodium chloride, equals to their charge. Sodium going to be +1, chloride be -1. The sum of oxidation numbers for all atoms in a molecule or polyatomic ion equals the charge on the molecule or polyatomic ion. That means sodium chloride has no charges, so will be the summatory must be 0. +1 -1 is 0. Hydrogen in a compound. So if it's a bond with non-metal, it will be +1, and if it's non-metal, -1. Oxygen in a compound is usually -2. And when you have peroxide, but it's not common, you're going to find -1. Halogens, when not central atoms, when it's writing first or with bonded with oxygen, will be always -1. Okay, so that is the main rules that you need to pay attention in order to assign oxidation numbers. So I think the best thing here is practice. If you practice, you're going to understand better. First, let's go to this problem here where asking us which reactant undergoes oxidation. So we need to know the rules to assign the oxidation numbers. So we have the zinc solid. So let's in the copper ion producing zinc ion and the copper solid. So now the Knox number for zinc, which is a neutral element, would be 0, right? While the zinc 2 plus, we know that would be equal to the charge. It's an ion. So 0, 2 plus 2 we are seeing here that it's increasing if the Knox number. So the oxidation number is increasing. So what happened over here? So when you look to the copper 2, so in one side it's +2, the other is a neutral element 0. So we have a reduction, right? So the Knox decrease. So what happened over here? They gain electrons. So copper is the oxidizing agent, okay? Because of the Knox reduce it. They are reducing, so they are oxidizing agent, while the zinc is oxidizing, so zinc is the reducing agent, okay? Pretty easy. Just remember why this happened, because if it's zinc oxided, that means zinc made copper reduce. So that's why zinc is the reducing agent. Okay, so pay attention on how to indicate your to find out the Knox. So let's assign oxidation number for some compounds over here. We have some ions, ammonium, nitrate. Okay, so let's start with the ammonium ion. So we have the chart. Remember, when you have the chart, the summatory of the oxidation number must be equal to the charge. In this case, +1. So a hydrogen, we know that it's +1. There are 4 hydrogens, so the total is 4. So overall, the charge is +1. So nitrogen must be -3 because +4 - 3 will be +1. So it's equal to the summatory of the charge. Okay? So have a -3 +4 is equal +1. Got it? So that is the charge that we see on our polyatomic ion. So let's go to the nitrite ion over here. So nitrite ion, we know oxygen is -2, and we have a 3, so it's -6. The overall charge that you can see is -1. So yes, I made a mistake. I used the hydrogen again, so it's oxygen. So -1. So the summatory of your charge must be -1. So nitrogen must be +5 because -6 plus 5 will be equal -1, which is the charge of our polyatomic ion. Let's go to nitrogen dioxide. So the summatory of the charge here must be equal 0, right? Because we don't have a charge. You don't see any sign over there. So oxygen, we know that is -2. There are 2 atoms of oxygen, so it's -4. So overall, the charge must be 0. So nitrogen must be 4, because 4 minus 4 is equal 0. Okay? That's it. That's all. It's easy to find the Knox number. You just need to know some rules. Find the oxidation number of the selected element over here. So well, let's start with the vanadium. So we have the extreme ones, potassium and oxygen. You know the charge because potassium is the metals. So the metals in the group 1, we know that will be equivalent to the charge of those metals, which is +1, and oxygen is -2. Make equation. So we know that I have 4 times 1 plus 2 times V that we don't know the charge, the Knox number or oxidation number, plus 7 times -2. So then with this equation, so we know we're going to find the vanadium oxidation number. Okay? So the oxidation number that you see there, 1, is the oxidation number for all the metals in the group 1. You know how to identify that, right? Group 1 plus 1, group 2 plus 2. Okay? So that oxygen is -2. Remember, normally oxygen is -2 unless it's a peroxide when the oxygen is -1. Okay? So solving this equation, so will be -10 plus 2V equals 0. So we're going to find the V. So how much is going to be the V? V will be equal, just think, just calculate. Now it's a simple equation that you do easily, okay? So the oxidation number for vanadium is 5. You can double check, so we have 4 times 10 because 2 times 5 is 10, minus 14 must be equal 0. And it is, because we don't see any charge over this compound. Let's see in the ion over there. So we have a polyatomic ion, and we need to find out the oxidation number for sulfur. So what we're going to do is make equation again. And we have S minus 5 equal -1. So sulfur will be, what is the oxidation number for sulfur? Why we put it -1? Because the charge of the polyatomic ion. Sulfur must be +4. You can always double check, put in the values in our equation again, and check if you really have -1. And in this case, would be 5 minus 6 is equal -1. So it's easy to solve. Pay attention on the rules. Don't forget. That's it. That's all.